Okay, Michael, thank you again for being here. So tell us a little bit about what is your role at Microsoft? You're a program manager, and what do you work on?
Yeah, I work in Windows, and specifically, I work on pen and display technologies.
That's awesome. And so, pen and display technologies, a bunch of that stuff was announced yesterday. And so, we're specifically going to be talking about pen and inking. Now, I have to say, as I've been working from home and then the whole last year and a half, I kind of developed an obsession for inking devices. I bought a bunch of e-ink tablets. I have a lot of kind of an obsession with, trying to have the most realistic pen to paper experience possible. And it seems like some of the stuff that was announced yesterday is going to be completely up my alley, right?
Absolutely. In Windows 11, we're providing developers with APIs that allow them to incorporate tactile feedback into their code so that they can utilize the new capabilities of the Surface Slim Pen 2, which is an Office piece of hardware. Referring
Yeah.
back to what I just said about tactile feedback, we call it tactile feedback because people already understand that feeling in their fingertips, like the bumps of braille as you go over buttons on an elevator, or the sensation of your lead from the pencil hitting the paper. And it's a really awesome way to create a new feeling for your users.
Okay, so how is this different from the previous, and I guess maybe even the current pen capabilities? What's different about this experience?
So the thing is, it's completely new for us. This is a new capability for a pen, and it's enabled on particular devices that run Windows 11. Today, we'll be going through a sample app to give developers a sense of how they can use these APIs.
No, that's really exciting. So you're going to be showing us some demos, right, to show how people can incorporate the new haptic and tactile stuff into their apps.
Yeah, today we'll be walking through 5 demos where we walk you through how natural the pen feels against the screen and how users will be able to feel those interactions, and of course, how to be able to make use of those experiences in your application. So I want to make a quick note though. These APIs will use a more technical term than the tactile feedback I've been using before. We'll use the term haptics, which refers to
Haptics.
the mechanism. Yeah, haptics, which refers to the mechanism for playing those signals. So in the
Okay.
next demo, we'll be going through and we'll be using haptics.
All right, let's go to the first demo.
The first thing you see here is the standard ink canvas control. It's completely unmodified, and the great thing is that it provides haptic feedback for free for each of the built-in brushes. Here, I'm using the default pen, and I get a smooth, sturdy feeling, much like a ballpoint pen on paper. Now, as I'm doing my inking, it's also reacting to the velocity and the pressure that I'm applying on the screen to change the signal to better simulate what it actually feels like on paper. Now, when I switch to the pencil, I get something more scratchy, and it feels like a pencil on paper to me, which is pretty different from the pen that I just felt in the previous example. Lastly, I can switch to the highlighter, and here I get something smoother, like taking a real highlighter across paper. This one's really nice as you're doing these big, broad motions as if you'd be highlighting a bunch of text. These different feelings really combine to create a more intuitive inking experience, and I can't wait for all of you out there to get to experience them for yourself. Now let's take a look at the code for this. Here you can see my XAML, and all I've done here is add the default ink toolbar, and down below, the default ink canvas. And if we take a look at the code behind, you'll see there's absolutely no new code here required for haptics. All that I'm doing here is setting the size of my canvas.
That's awesome. Okay, so that was just showing us how all apps are basically kind of going to get haptics for free. But what about apps that might have their own custom inking experiences? Because I know that that's already pretty common. So how do they add haptics to their experiences?
Great question. We give developers the ability to detect if a pen device in code supports haptics, and then if so, what signals it supports so that they can select a signal and play it back. So that way you can set your desired haptic signal, or waveform as we may call it, and stop it eventually. In the next demo, we'll show you how to detect a pen device and then query its haptic capabilities so that you can figure out what experiences you want to turn on.
All right, let's go to that demo.
So here we have a simple demo that looks to see when a pen is in range and then determines what haptic features it supports. Here, you can see when I bring a supported pen in range, it outputs the various features that this pen supports. And if I bring a pen in range that doesn't support haptics, it tells me that as well. So, how can you determine what a pen supports? To do this, you use the pen device object to get access to its simple haptics controller. Now, I'll be doing this in the pointer entered event for my app's main canvas, and this is going to fire as soon as the pen is in hover range of the screen. In the event handler, the first thing I'm doing is checking to see if the current pointer device type is a pen. If not, I'll exit out. If it is, I then attempt to retrieve the pen device associated with that pointer event. Now this will only return a valid object for pens that provide advanced functionality, like either pen ID or in this case, haptics. So again, if it's null, I'll exit out. Lastly, I then attempt to retrieve the pen device's simple haptics controller, and this is the last check that you'll do. If this is null, the pen does not support haptics, and again, I exit out. Now that we have the simple haptic controller, we can see what specific waveforms and features this pen supports. This is important because not every waveform and feature is required to be supported by every pen, which lowers the barrier of entry for pen manufacturers. However, we do enforce that two baseline waveforms are supported, ink continuous and click. These provide coverage for a large range of scenarios, which is why they're always required to be supported. The next couple of demos will show sending a desired waveform or falling back to one of these if it's not supported. But for now, we'll just query the capabilities to output what is supported on this pen. So, to check if a waveform is supported, you iterate through the simple haptics controller's supported feedback collection to see if the desired waveform is present. Here, I'm running through each of the possible waveforms and adding to my text string if it's there. In addition to waveforms, there are a handful of additional features that a pen may support. This demo will only show how to use the intensity feature, but here you can see how to query for each of these additional features. They include intensity, play count, play duration, and replay pause interval, and you can find more information about all of these in the API documentation.
Very, very cool. Okay, so are these all of the waveform interactions, or are there others as well?
So some of the ones you saw enumerated in the if clause are going to be inking interactions. Specifically, we're going to be supporting the following waveforms. The first is ink, which, as we mentioned in the demo, is required to be supported on any haptic-capable inking hardware. And this is what we expect people to associate with the default pen feel. So if you're just adding like a ballpoint pen into your program, you want to have something for simple inking, go with ink. And definitely, in case there's other features that aren't supported, ink is a great fallback to make sure that you have that basic inking experience. The next is chisel marker, which you can really think of as a highlighter, kind of like a
Nice.
squishier feeling.
Nice, I like that.
Also, yeah, highlighter is really fun to use. There's also pencil, which is one of these hero kind of interactions, brush, marker, and eraser.
Which one is your favorite?
My favorite's definitely pencil, just because it's been one of those really hard to simulate kind of feelings. When you use a device and you have like your pen on your tablet and you don't have that kind of feedback, it kind of distances you. But once you have that feedback that's convincing, it's really awesome and engaging.
Yeah, I can't wait to try it out. I do have a question for you because this stuff is really awesome. Can any app take advantage of this? Like, can a Win32 app use haptics?
Yes, you can use the pointer ID included in the WM pointer messages in order to get the pen device, which in turn lets you get access to the simple haptics controller, which is where you can make all the calls you need to.
And what about apps built with the WinApp SDK?
Yes. As of the current WinApp SDK preview, which you'll hear more about today, it allows you to access the pen device from a pointer point, which in turn lets you get access to the simple haptics controller, just like a Win32 app.
Very, very cool. All right. Now you're going to show us some other stuff about how, I guess, you can send and interact with signals back and forth between the waveforms, right?
Absolutely. We'll be, in this clip, showing you how to send inking feedback. Now that you know how to enumerate it, determine what's supported, and remember, this feedback is designed to simulate all of the writing tools like pen, brush, pencil, and marker. So if you're doing your custom inking app, you'll want to pick the patterns that match your brushes best so that you can send haptic signals to them. We'll show this coming up.
All right, let's take a look.
In this demo, I have a dropdown that lets me choose what feedback I want. Now, a note for you watching, I won't actually be drawing ink in this box. Rather, I'm just using it as a place for me to put the pen down and have haptics get fired as I move it around. You'll see a message below the box indicating what feedback is being played. So now, when I touch my pen down in the box below, I begin to feel the proper haptic feedback. In this case, it's the ink continuous feedback, which corresponds to the ballpoint pen you saw in the first demo, and is one of the required waveforms that all pens must support. Now, I can choose the brush feedback, which gives me a silky, soft feeling, like bristles sweeping underneath my pen. Lastly, I'll choose the marker, which feels velvety and bold, like a permanent marker. Now here, I also have a slider that lets me adjust the haptic intensity. Once this is set, I now feel a less intense version of the feedback. So now, let's see how you can manually invoke feedback like this in your app. Again, I'll be using the pointer entered event. First, I do that same check that you saw before to make sure that the pen supports haptics. Then, I have a little helper function to set the waveform based on what's currently selected in the dropdown. This attempts to set the waveform to what is currently in the dropdown by checking to see if the selected waveform is in the Simple Haptics Controller supported feedback collection, and then setting my selected waveform to it. Here, you can see the full set of possible inking waveforms. These are brush continuous, chisel marker continuous, eraser continuous, galaxy pen continuous, ink continuous, marker continuous, and pencil continuous. If the waveform is not supported, I instead set it to be ink continuous, which remember is guaranteed to be supported by every haptic enabled pen. Next, I check to see if the pen supports changing the intensity of the signal. If so, I call send haptic feedback, passing in the current waveform and the intensity value. If not, I simply call send haptic feedback without passing in the intensity value. Now, it's important to note that for inking feedback types, the feedback does not start once send haptic feedback is called. Rather, it will begin as soon as the pen tip touches the screen, and it will likewise stop once the pen is lifted. This is why this should be set on the pointer entered event rather than a pointer pressed event. Lastly, I look for the pointer exited event to call stop haptic feedback to ensure that the pen does not have a saved state, which could cause it to play haptics where I don't want it to the next time it comes in contact with the screen.
This is really, really cool stuff. So now what about other experiences or interaction waveforms? What else can you do?
Well, we have some other waveforms that are called interaction waveforms. And examples of these are success, error, hover, press, release. But these make more sense in specific contexts. For the majority of short interactions, we really recommend using a waveform called click. And this one is really crucial to use because just like the ink waveform, the basic ink waveform that we use as a fallback, it's required to be supported on every haptic device. So we expect our developers to use this one more frequently. And we're going to show you an example where we do just that.
Let's take a look.
Again, I've got a dropdown that lets me choose which waveform to send. However, this time, I have a button that plays the feedback when pressed. So now, every time I press the button, I'm getting a little click feedback. This is just a real nice little sensation coming into my hand to confirm that I've successfully pressed that button. Now I'll switch over to the error feedback. Here when I press the button, I'm getting this little double burst coming into my hand to really draw my attention to it and let me know that something may have gone wrong. And, as with inking feedback, I can also adjust the intensity to get a different feel, as here the feedback now feels lighter in my hand. The code here is very similar to the inking feedback demo. Again, I'll be using the pointer entered event handler to make sure the pen supports haptics. I'll also be using the button's click event handler to trigger the haptic feedback on demand. So first, here's the exact same code you saw before for checking the haptic capabilities of the pen and getting me a handle of the Simple Haptics Controller. Now, here in the click event handler is where I'll actually send the haptic signal. First, I check to make sure I have a valid haptics controller. Then, I again have a helper function to set the current waveform based on what's selected. Here, you can see the available interaction waveforms. These are click, error, hover, press, release, and success. Like the inking feedback demo, I make sure I can fall back to a waveform that's guaranteed to be supported. In this case, that's the click waveform. Next, I do the exact same call to send haptic feedback as in the previous demo. The only difference is that, since this is an interaction waveform, it gets played immediately versus when the pen tip hits the screen.
Okay, I like this a lot. Now I have a question for you, Michael. So in that last demo, I'm only getting haptic feedback like when there is a pen input, but can I like trigger haptics even when I'm not entering in any input?
So this is a great point of clarification. The answer is no. Haptics is really closely connected to input, and it shouldn't be triggered when it doesn't relate to something that's happening with your input.
Okay, so like when should I be considering when to use haptics?
You should be considering using haptics when you're directly responding to pen input. So inking, the obvious example we've already started with, but there's also interacting with controls. For example, if you click on a button with your pen, it's really natural to have a click response come from that pen right afterwards. Or when you move the pen to hover over an interactive object, like a 3D model, you could use the hover waveform. In this next demo, we'll tell you how you can transition between those two types of feedback that we just talked about.
Okay, awesome. Let's take a look.
Here, I have a canvas with some grid lines drawn on it and a box. I can use my pen to drag the box around, and when I do so, I'm sending the ink continuous feedback as I'm dragging it, which starts at the same time as the box changes color. This is giving me a really nice physical sensation as I move the box around. You'll also see that I get some previews that will allow me to snap the box to the grid lines. When the box enters into one of these snap zones, I get an additional buzz in the pen, coinciding with that preview visual being drawn. So here, I'm getting really nice constant feedback, but it's also paired with a noticeable bump every time I hit a new snap target. Finally, if I release the box and it snaps, I get another haptic buzz telling me that it's successfully snapped into place. In the interest of time, I won't jump into the code behind this, but it's really just combining the previous two examples together, along with some code to handle moving the box and some math to figure out the snapping behavior. If you want to explore the code yourself for this, or for any of the other demos, it'll be included in a new pen haptics sample going up on GitHub.
Awesome. And I think actually you have like a URL where people can get the GitHub samples and the other information, right? That's at aka.ms/penhaptics. Is that right?
That's totally right. aka.ms/penhaptics.